Hi everybody and welcome. Today we're going to be talking about square roots. So your goal after watching this video should be able to add, subtract, and do some multiplication with square roots. So with that being said, we're going to take a look to start off. So a square root is not actually a physically square root of a tree. It is, again, a skill that we're going to be going over today, but looking at something like this. That is our square root sign, that's our radical. So something like square root of 64. A number times itself is a square root. So the square root of 64 is 8. So again, 8 times 8 gets us 64. Well, if you're thinking even closer, you might say, well, Mr. Reardon, negative 8 times negative 8 is also 64. Well, and that's also true. So square roots here, we're going to see positive and negative roots, but that's the idea. And a real world application of this not only is the square root of a tree, but if you're looking at doing the Pythagorean theorem or solving for an unknown length in a triangle, you will need to use a squared plus b squared equals c squared. So again, another application of where roots come in. And also, we're going to be doing some functions here in our coming unit where we're going to be looking at not only square root functions, but when we're solving, we're going to need to know some square roots to do that. So an important skill comes up quite a bit. Hopefully today will be a little bit of review for us and taking a look at some of the important things we need to know about these square roots. So with that being said, we are going to jump in here to our definition. So today, our new skill, our review skill, is square root. And this is a number that produces a given quantity when multiplied by itself. We actually kind of talked about this already, but if we have something like the square root of 4, well, we know that 2 times 2, so 2 times itself equals 4. We also know that negative 2 times negative 2 gives us positive 4 as well. So the answer to this is actually both positive and negative 2. So you'll notice this, all square roots have both positive and negative answers, so that is an important thing to remember. A second thing to remember is that if you had a negative number inside there, like negative 4, well, nothing times itself can get you a negative number. If you have positive 2 times positive 2, you get a positive answer of 4. Negative 2 times negative 2 also gets you a positive answer of 4. So answers like this are imaginary. So these do not exist. So if you ever get a negative square root, you won't be able to find that value. It's an imaginary number. Other terminology, this is called a radical. The number that goes inside of it is called the radicand. So the number inside is the radicand. The actual symbol that goes on the outside is the radical. Perfect square roots, so something like 4 gets you plus or minus 2. So again, it's called perfect because it evenly divides out. An imperfect square root is a rational. So something like the square root of 5 is called a rational because the answer just keeps on going and keeps on going. So you punch in the square root of 5 into your calculator, you'll get like 2.23606, ... Keeps going on forever. It's irrational. So unless you have a perfect number, you won't get an answer. But if you don't, you'll have a whole lot of decimals that you'll need to do some rounding with if you want to get an estimate. But again, any estimate gets you less accurate, so sometimes it's best to just leave it as the root of 5. All right, so now we're going to start going in a little bit more closely into some of our examples. So some square roots here. The square root is 16. Again, we can either punch that into our calculator or just see that 4 times itself is 16, and also negative 4 times itself is 16. Secondly, we want to evaluate these expressions in order. So we're going to evaluate the square root of 64 first, which is plus and minus 8. And then there's a negative on the outside that we can distribute in. So it actually won't really change our answer. We'll still have negative 8 and positive 8 as answers to that expression. Now that third one is where they're trying to get you. There's a negative inside. We know that nothing times itself can give us a negative number, so we know that this answer actually does not exist or is imaginary. So keep going through, see if you can do some practice with those remaining 3, and see where it gets you. Now to get us a little bit more complicated into some more useful skills that we're going to need, what about cube roots? So cube root, you can probably guess here, this is anything, not just times itself, but anything 3 times over. So the cube root, and we write cube here, third power, of something like 8. Well, let's take a guess. Well, 1 times 1 times 1 just gets us 1, so 1 is not the answer. What if we did 2 times 2 times 2. Well, 2 times 2 is 4, times 2 is 8, so that works. Okay, now let's see if that trick we did before works as well. So like negative 2 times negative 2 times negative 2. So is it like plus or minus 8? Well, negative 2 times negative 2 is positive 4, and then positive 4 times negative 2 is negative 8. So actually, negative 2 doesn't work. The only answer to a cube root question is the correct value. So positive 2 is the only one that works. If we look at this example here, we just solved this one actually. Negative 2 times itself 3 times gets us negative 8. So only negative 2 is the answer there. Excuse me. So I need a drink of water here. Sorry about that interruption there. But anyways, keep going with those last two examples, and you'll be able to do just like we did up top there. So something times itself 3 times will get you the cube root that you're looking for. All right. So let's keep going. We did squares, we did cubes. What if it's even bigger? So the nth root. So when we're writing this out in our radical, it's going to be to whatever the power is, and that power belongs there. So to the x power, it would go right there. So if you have like to the 4th power, you'd write a 4 there. To the 3rd power, again, the 3's there. In the 2nd power, it's just assumed. So if there's nothing written there, it's to the 2nd power. But that's the idea. So again, we can look at this here. 3 times 3 times 3, that's 3 to the 3rd power, gets us 27. So our answer to this question is only positive 3. If we look at something like 625, though, we'd have to see what to the 4th power, or what times itself 4 times, can get us to 625. Well, if we look at positive 5 to the 4th power, that equals 625. And also, negative 5 to the 4th power equals 625. So even-numbered roots here, even-numbered roots have both positive and negative solutions. So the answer to this one, to be specific, it equals both positive and negative 5. But odd number roots, like to the 3rd power or 5th power, for example, share the sign of the radicand, or the number inside. So plus or minus 5 is the 4th root of 625. We'll go over how to punch that into your calculator if you don't know how to do it in class as well. But some good practice there. So just beware, look for the little number there. It's going to tell you what power we're looking for. All right, let's keep on moving. So now we're going to look at ways that we can write square roots using exponents. So the definition of a to the 1 over n power is just saying it's a to the 1st power and then the root to the n power. So whatever is on top follows the a inside, and whatever is on the bottom is on the root outside. So for example, if we had 2 to the 1/2 power, this just equals 2 to the 1st power and then to the 2nd root. So the square root of 2 to the 1st power. If we had something like 3 to the 1/3 power, that would be the cube root of 3 to the 1st. And that's what that would look like. So we want to rewrite these expressions and simplify them. Okay, well, this is 25 to the 1st power to the square root. Well, we know that plus or minus 5 is the square root of that. So that is how we would do 25 to the 1/2 power. It's actually just saying, what's the square root of 25? So try that for the remaining two, see what you can get. And then finally, there's a couple more examples here that we're looking at today. So what happens if it's not 1 over something? Well, like we said just before, this would be 9 to the 3rd power, because whatever's on top goes with the radicand, or the number on the inside, and the radical, the number on the outside, is to the 2nd power here, so it's going to be the square root of 9 cubed. Well, can we simplify this? Let's see. 9 to the 3rd power gets us 729. And we're taking the square root of 729. Well, does that go in evenly? It looks like it actually does. We have plus or minus 27 as our answer here. So we want to do the same thing here. We would like to do negative 32 to the 2nd power. And then now we're going to do that to the 5th root. So see if we can calculate what negative 32 squared is, and then take the 5th root of it. All right, lastly, a to the negative m over 2 power. Well, this gets a little bit confusing for us, but let's try an example of a number. 25 to the negative 1 over 2 power. Well, negative exponents just mean that it's 1 over whatever the exponent is. So it's 1 over 25 to the 1/2 power. Well, we know from before that 25 to the 1/2 power is actually just the square root of 25, or the square root of 25 to the first power. So we just know that it's 1 over plus or minus 5. Or plus or minus 0.2, I think, if we have that to the decimal. So if you ever have a negative, it's just 1 over whatever it's asking you. So this is 1 over 27 to the 2/3 power, or 1 over 27 squared to the cube root. And again, we can punch that into our calculator and simplify this. We'd want to do 27 squared and then take the cube root of 27 squared. And we can do that for that last expression as well. So a lot in this video in terms of processes that we need to remember. I know that this is probably a bit of a review here. And again, if we didn't have a good background in this, that's okay. We can use this video as our learning point and our launching point for these skills. But again, finish up those practice problems. If you're not sure what to do, try to keep working at them, see if you can solve them, and bring your questions to class. We'll definitely answer them in small group time.